All right. So you've got it. Okay. Go ahead and work problems. I'll come around and help you. So if you're watching the video at home, pause it so you can copy things down if you haven't figured them out. It's not for you guys here. All right. Any questions on number A? Promise? All right. Number B. Doing okay? Watch it. Okay. I'll leave this up during the break so you can come copy down anything you're missing. Okay. I quickly answered this with 64, just like that. Not because I'm clever. What did I do here? I went back to what we're originally doing. What is this function here? Y. This is the horizontal line, y equals 8, right? So this is y, and this is f of y. Okay, so first of all, the fact that I'm using y doesn't matter, right? I can use any variable I want and ask you to do this. Okay. What is this curve? Here it is. This is the curve y equals 8, right? And what are we doing? We're computing the area underneath the curve between -3 and 5. What is this shape, folks? It's actually, we need one better than a rectangle. It looks like a rectangle here, but actually it's a what? Even it's better. It's a square, right? What's the width? What's the height? 8. What's the area? 64. Hopefully you did it the long way and also got 64. Okay. Let's go ahead and make a comment on this. Let's go ahead and make a comment on this one. Okay. Just to see how where the fundamental theorem of calculus is coming in from. Okay, here was y equals 8. You don't have to write this down if you don't want to, because we'll go in more detail later. From 3 to 5. Okay. What did we do? Well, you guys who did the integral, which is what I wanted you to do, you found an antiderivative. The antiderivative of 8 was what? Well, it's actually 8 what? 8y. Make sure you've got y's there, not x's in your work. Okay. So here we have y, and this is the curve. This is the curve f of y equals 8y. Okay, that's the antiderivative, right? Now, what this is saying is that rather than computing area, which is a what type of problem? It's a two-dimensional. This is Calc 3 right here. Rather than computing area, which is a what type of problem? Two-dimensional problem. We go ahead and we plug into the function. We look at there's that function 0, and then when we plug in 8, we get 8 comma 64. And what do? We look at the difference between the two y values. What is the difference between these two y values? 64. So rather than computing the area, we look at the difference in the antiderivative values. There is something there. There's something to spend some time thinking on. Okay? All right. We'll do more of those in more fundamental theorem of calculus questions in 5.3. Okay. I don't have much to say about letter D. You got to know your derivative rules, or you can't do your antiderivative rules. All right? Okay. Any questions on D? Okay. Letters E and F were an exercise in the way sometimes authors will write things, which can be frustrating. Okay. What is the understood number being multiplied to dx there? 1. It can't be a 0, or there would be nothing there, right? The understood number is 1. Okay. So it's 1 dx, and what is the antiderivative of 1? It's x. We okay with that? All right. Letter F is, again, authors do this. You know why? Because if they write the problem this way, it saves them 1 millimeter of line space. So I think it's easier to see the problem if you rewrite it. So rewrite this integrand this way. Okay. So it's customary, if you've got a fraction for your integrand and the numerator is 1, to just put the dx there up in its place. I don't know why people do that. Only I feel I probably ought to do it too, so that way you are exposed to it. Okay, not that I like writing it this way. I think it's silly. Okay, antiderivative of the natural log of x is, antiderivative of 1 over x is Natural log of the absolute value of x. Do you need that absolute value? Yes. Technically, in this problem, you don't. But if the limits of integration were negative, oh yeah, you would definitely need it, or you wouldn't be able to evaluate it. Okay? Of course, the natural log of 1 is 0, and since 2 is already positive, do I need an absolute value in my final answer? No, you don't. But you put it there, there's nothing wrong with that. All right, during the break, if you didn't get G, I'll let you take a look at it. G is simply an exercise in rewriting things with your power properties. Okay? For instance, the square root of x is x to the 1/2 power. Now this, to answer this question, I'm going to say, oh, this is going to be x to the 2/2 times x to the -1/2, which is x to the 1/2. This one, what did I do here? In my first step, I divided this, and different people did this different ways, and some of you, I liked your way better than mine. I divided this into both terms in the numerator. And I also rewrote it as x to the 3/2 and x instead of x cubed square rooted. Okay? And then between here and here, I said, well, that's x to the 10/2 divided by x to the 3/2. Subtracting gives me x to the 7/2, etc.